Oops. Oh,
guys, I forgot to show you the last two. Guys, the last one, we got 0, so yes, it's a root. We did not get 0, we got 33. That is not 0, so no, it is not a root. Okay? Sorry about that. Forgot those last two.
Are we getting a new handout today or taking notes on it?
No, we're taking notes today. And your homework is 4 problems, so I didn't print them.
Save it paper, yes.
All that work for number 12?
No. Okay. Alright, here we go. Guys, today we're going to look at something that's called Pascal's triangle. Pascal has lots of uses today. We're going to use it as a shortcut method for expanding binomials. Now, to prove that it's a shortcut method, because sometimes my students don't feel like it's a shortcut, I'm going to show you the long way. So here we go. This is painful, but I'm going to do it. If I were to expand this the long way, no, you just watch and be thankful you don't have to write this. Okay, so I'm going to multiply those 2 and those 2. And when I do, I get 4x squared minus 4x plus 1. You would probably have to show a little more work, but this was also 4x squared minus 4x plus 1. And then that's this. And then what I'd have to do is start individually distributing. Yay! So I'm going to distribute this through. And when I do, I get 16x to the 4th minus 16x cubed and then plus 4x squared. Then I have to distribute this through. Alright? And when I do that, I get negative 16x cubed, and then I get positive 16x squared, and then I get, nope, it's negative 4x. And then I would have to do the last one, the 1 all the way through. And so I get 4x squared minus 4x plus 1. And then I have to add all the like terms. Did y'all ever learn to write it where you stack them so your like terms are already?
Yeah.
Okay. Well, maybe some of you did, maybe some of you didn't. So if I add like terms now, I have 16x to the 4th minus 32x cubed. What is this? 24x squared, and then negative 8x plus 1. Wouldn't it be nice if I were done? I'm not.
Oh my God.
I'm not. I'm still not done. I have to distribute the 2x through, and then I have to distribute the negative 1 through. Alright, so here we go. 32x to the 4th minus 64x cubed, and then plus 48x squared, and then minus 16x, and then plus 2x. Then I have to distribute the negative 1 all the way through, minus 16x to the 4th plus 32x. This is cubed. Thank you. Squared. And then minus 24x, and then plus 8x, and then I'm almost done. But I'm not done because I still have to add like terms. So I get 32x to the 4th minus 80x cubed plus 80x squared minus 40x plus 10x minus 1. You're right.
We done?
Wait.
Let's do it, please.
Check your work.
3,
Who you call?
2.
Don't call us.
What did I do there?
He's 4.
Oh no.
He's 32x plus.
Oh, this is 5. 4,
Yeah.
3, 2, 1. So this is 4, 3, 2, 1. So this is 5, 4, 3, 2. Painful. And I couldn't have done it right if Juan hadn't corrected me like 12 times.
Yeah.
So, 1 was equal to 1, 2 was equal to, we don't have to do it this way. Okay? We don't have to do it that way. There is a shortcut. And this shortcut comes from Pascal. Alright, so you don't have to know how to do that. We're going to do the shortcut. Okay? Because I want you to, real quick, I want you to notice, and this is only because with Juan's help, I'm decent at math. Okay? Alright, so what is Pascal's triangle and how are we going to use it? Tomorrow we'll look at some other fun uses for Pascal's, but I want to get through today's lesson. Okay, so Pascal's is a shortcut that gives us the coefficients we need to expand a binomial. And it comes from this. It comes, yeah, these are your notes. These, we finally got to your notes. The last one was just a poor job at trying to be entertaining.
Good job, Juan.
Good job.
No, not really.
Yeah, I can. Whenever.
Okay.
He just didn't.
He already knows it. Yeah. Alright, so, anything to the 0 power, even if it's x plus y. What is x plus y to the 0? 1. Anything to the 0 power is 1. Now, the next one is to the first power. And when we have it to the first power, all we're looking at is our coefficients. Understood 1x, understood 1y. So we have a 1 and a 1. Okay? Now, if I were to expand this out, just take my word for it. It's x squared plus 2x, y, plus y squared. So what's the coefficient of the first one? 1, and then 2, and then 1.
I got the next one. I'll do it.
Okay.
1, 2, 3.
No.
Okay.
I got it.
Alright, the next one. This, let me change colors. This gives us x cubed plus 3x squared y plus 3xy squared plus y cubed. I just know it. But this is what happens when you cube this. So what coefficients do I have? 1, 3, 3, 1.
Wow. This is the triangle.
Okay, it is a triangle. Alright, so if we did it to the 4th, this is x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. So what are my coefficients? 1, 4, 6, 4, 1. Okay, I want you to look and see if you see any patterns. Okay? And I want you to predict what you think the next row would be. Now, if you have already had this lesson today, please do not shout out. That's not fair. It's kind of like those people that go the first day, they release a movie at midnight, and then they post all the spoilers on social media. Okay, I like it. I heard a 1 and a 5. So far, so good.
9.
It's 10.
It's 10.
Okay, so if I give you that 10, can you figure that out?
Kids call.
6 plus 4 is 10. So 10 again.
2 plus 2 is 4.
Can I not shout it out yet?
You just did.
I know.
Are you into that one?
Okay. Alright, so one way to build Pascal's. And you're going to see it clear as day now. If you add these two, you get that. if you add those two, you get that, and 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 that, and that, and that. Okay? All right, everybody, write the 6th line. Everybody, you got it now.
In the
You got this. I know what I'm doing. Whole life.
Stop shouting out.
Chill out. Chill out for a
Does it go on forever? It can, but we're not going to go forever. I promise. Alright, so what is it? 1,
6, 15, 20,
6, 1. Alright, do you see the beautiful symmetry?
Yes.
Yeah. Did you notice things like this is all ones and this is all ones? Did you notice other weird things like this counts down and this counts down? There's some other really cool things in here that we're going to talk about tomorrow before we go do our little around the rotunda game. And we're going to skip warm-ups tomorrow, and I'm going to show you lots of super cool applications of Pascal's. But let's go back to this painful example. This example was 2x minus 1 to the 5th. So I'm going to do it again.
Just because pain.
So 2x minus y. Was it y or 1? 1. 2x minus 1
To the 5th.
to the 5th. Alright, so what we would do is we would use that row of Pascal's that the second number was a 5. Do you remember it? It was 1, 5, 10, 10, 5, 1. You can still see it on your page. Okay? And we're going to take those. 1, 5, 10, 10, 5, 1.
Wait, did we do the same we did yesterday now?
No, this is kind of interesting. Those are our coefficients. And then what we do is we take this first one, and we start with that first term, 2x. And where we start, we raise it to the power that it's being expanded to, the 5th power. So we raise that to the 5th. And then beside the 5, we do 2x, but this time we go down a degree. So now we're at the 4th.
And then 2x to the 3rd.
And then we keep going. So then we do 2x to the 3rd. And then we do 2x to the 2nd. Now 2x to the 1st. And finally 2x to the 0. Alright, so we've gone completely through with our first term. Okay? Now we're going to take a look at the last one. It was -1. So I'm going to come over here where I stopped. And I'm going to start with -1 to the 5th. And then I'm going to go back. So this would be -1 to the 4th. And this would be -1 to the 3rd. And this would be -1 squared. And this would be -1 to the 1st. And this would be -1 to the 0. Now, a couple ways you can check to see if you're doing it right at this point is if this is the 5th power, then these two should add up to 5. Add up to, add up to, add up, add up, add up. They do. They should all the way across. And if they don't, you've messed something up. So do a quick check before you move on. Now, what this is we're going to treat, whoops, I meant to go back to pen. We're going to treat this like a single group that we add to this. that we add to this, that we add to this, that we add to this, that we add to this. Okay? I want to see the brackets around them. So go ahead and do that.
Is it okay?
There's so much going on here. I did not
Are we gonna have so much more if you do this?
Yeah. I'll give you all the way across the page.
Yes, please.
Yes.
Is that a 1 in front of the two on
Right.
the first bracket?
Right here and right there are both ones. Yes. We always start and end with a 1.
How do you know to use the 1, 5, 10, 7, 5?
Because it's the 5th expansion, because it's a 5th power, we're going to start with the 5th expansion. And the way we know that is just by looking at the second number. The second number is the expansion. So that's the 5th expansion, that row. Good question. So that's how we knew to use that row of Pascal's triangle. Okay. Now, this part is not really hard, but if you try to do too much at once, you're going to confuse yourself. So don't do it. Okay? We're just going to do a little bit at a time. Okay. Order of operations tells us we have to deal with these exponents, the powers, before we can do anything else. So everything that's raised to a power needs to be raised to a power. So this becomes 1. 2 to the 5th is 32. X to the 5th. And anytime we raise any number to the 0 power, it's 1. So that is 1 times 32x to the 5th times 1. Don't zone out. If you zone out, when you come back, you're going to be lost. Okay. All right. I just raised this stuff to the powers. 2 to the 5th is 32. 2, 4, 8, 16, 32. 2 to the 5th is 32.
Quick question, how do you calculate this?
Yes.
Okay, cool.
All right. So if when I multiply all that out, that is 32x to the 5th. Because 1 times 32x to the 5th times 1 is 32x to the 5th. Okay. Now we finished the first bracket. Now we move on to the next bracket. You do it one at a time. Just one at a time. So this is 5 times 2 to the 4. 2, 4, 8, 16. 2 to the 4th is 16. Alright, what is negative 1 to the first power? Negative 1. So now, I do 5 times 16 times negative 1. 5 times 16 times negative 1 is negative 80. So this is negative 80 x to the 4th. And now we're done with that bracket. We move on to the next one. Okay? So this is 10 times 8x cubed times, what is negative 1 squared?
Negative 1. Negative 1 squared is 1.
1. So this is positive 80x cubed. Ten times 8?
10 times 8. 80.
Yeah.
12.
Yeah. Alright, now we're done with that bracket. Now we're looking at this bracket. We have 10 times, what is 2 squared?
4.
4.
10.
And negative 1 to the 3rd is negative 1. So we have 10 times 4 times negative 1.
Negative 40x.
Negative 40x squared.
So you always leave the exponent or the power on there with it.
Oh, yeah.
You don't have to. Okay.
Pascal, how lies now?
Okay, the next one is 5 times 2x times 1. 5 times 2 times 1 is 10. And the next one is 1. Anything to the 0 power is 1 times negative 1. What is 1 times 1 times negative 1? Negative 1. Is that what we got earlier, Warren? Yes! Okay, so I know y'all think that's confusing because we're not good with multiplying. That's why it's hard. So, that's it. Alright, so, do you see how much work that took?
Yeah.
First is, this is the same problem I did a second ago. This is the same problem. Okay, do you see how much work this was? And I got everything, the exponents wrong? Yeah, same problem. So this one took like a full page. That one took a full page. This one took almost nothing. 2 lines. Okay. Alright, this is number 1 on your homework. So those of you that have been sitting there staring at me, probably want to write this one down.
Do you have all of them with chat?
Homework? Yeah.
Okay.
Yeah. Okay.
This one's pretty easy.
Those were the notes. This is our first homework problem.
Okay, at least it's
All right,
the 4th.
so I do not have Pascal's triangle memorized. I'm not going to bother because it's too quick to write. So I got 1, I got 1, 1, I got 1, 2, 1, I got 1, 3, 3, 1, I got 1, 4, 6, 4, 1. Okay, that row is what I need for a binomial that's expanded to the 4th power.
Isn't that the 5th power though?
Okay, that's a 4.
Yeah.
It's an ugly 4, but it's a 4.
The triangle you made. 1, 2, 3, 4, 5.
No, the first one is a 0 power.
Okay, cool.
So, yeah. So the way you can always tell is by looking at that second number. That second number tells you what power it is.
Okay.
All right, so that's why I start. I start with those. The 1, the 4, the 6, the 4, and the 1. 1, 4, 6, 4, 1. This is your first homework problem, so you would definitely want to write this down. We'll rewind in a minute and see how many times I got to say that. Alright. So what do? We take the first one and we raise it to the highest power. So 4. And then 3. And then 2. And then 1. And finally 0. And then we take the second term and we work the other way. So the second term is negative 4. Okay, so right here we start with, what's it? 4. 4. And then I go down to 3. And then I go down to 2. Then I go down to 1. And then finally 0. One at a time. All right, first bracket. We have 1 times x to the 4th times 1. What is that? X to the 4th. Second bracket. We have 4 times, got to cube the x, And then negative 4 to the first power is just negative 4. So on this one, I have 4 times negative 4. Very good. Negative 16 x to the third. Next bracket. I have 6 times x squared times positive 16. Okay, 6 times 16 is 96. Okay, and so it's going to be positive 96x squared. Okay, the next one is 4 times x times negative 64. Because 4 to the third, 4 cubed is 64, but because it's negative, it's going to be negative 64. That is correct. 4 times negative 64 is negative 256 x. And the last one is 1 times 1 times 256.
256.
Okay, a quick timeout. I know that 4 to the fourth is the same as 16 squared. Because isn't 16 4 squared?
Yeah.
What is power to a power? That's 4 to the fourth.
Yeah.
So I don't have my fourth powers memorized, but I do have my squares memorized, so I'm fine. That's why I knew it was 256, because I know 16 squared is 256. All right, so this is plus 256.
We're done.
And we're done.
That's it?
That's number 1 on your homework. Yep. Okay. So, the rest of them are on Blackboard, but they're also right here.
Oh.
Wait, you said 1 through 4?
We just did number 1. So you just have 2, 3, 4, and 5.
We do it for
Can we do it on our notes? Can we do it on
Yes.
and show it to you?
Certainly. Do it on your notes. All right. I'm going to pause the recording now.